Hello and welcome students to Make Pro classes, my official YouTube channel. Myself Piraj Mojumdar, Assistant Professor of Mechanical Engineering Department, GKCM, that is Greater Kolkata College of Engineering and Management under GIS Group. Welcome you to our new session of Advanced Welding Technology, where we will be uploading all the lecture series according to MacOut syllabus day by day. So keep in touch with us for getting daily updates. You can also contact me through 9433465217, that is my personal phone number, or even you can email me at pirasar@gmail.com. You can also connect me through social networking, that is Facebook page, which is known as Make Pro Classes. So let us start today's online session. Students, previously in this module 6 we have discussed on the weldability of plain carbon steels. Now in today's class we'll be having a discussion on the stainless steel, that is the weldability of the stainless steel. So let us begin today's online session. So in the previous class I have also discussed with you the weldability, definition of weldability. Now coming to the tool steels, these tool and die steels may be defined as special steels which have been developed to form, cut or otherwise change the shape of material into a finished or semi-finished products. Now properties of tool steels: slight change of form during hardening, little risk of cracking under hardening, good toughness, good wear resistance, very good machinability, definite cooling rate during hardening, definite hardening temperature, resistance to softening on heating, that is red hardness. Red hardness in reference to high speed steel and other cutting tool materials, the property of being hard enough to cut metals even when heated to a dull red color. In plain carbon steels we have previously discussed that we have got three types of carbon. The low carbon, that is the less than 0.3% carbon, it is having low strength, good formability. If wear is a potential problem, can be carburized, that is the diffusion hardening. Most stampings made from these steels: AISI 1008, 1010, 1015, 1018, 1020, 1022, 1025. Medium carbon steels 0.3% to 0.6% have moderate to high strength with fairly good ductility, can be used in most machine elements. Examples are AISI 1030, 1040, 1050 and 1060. High carbon steels having 0.6% to 0.95% have high strength, lower elongation, can be quench hardened, can be used in applications where surface subject to abrasion, tools, knives, chisels, AG implements. AISI 1080, 1095. Now talking about the weldability of carbon steels. Low carbon steels are considered very weldable. Medium carbon steels fairly weldable. High carbon steels are poorly weldable. Low alloy steels similar to medium carbon steels, and high alloy steels generally good. Weldability under controlled conditions. Main problem is brittleness due to martensite formation. Duplex stainless steel. It is a austenitic ferritic steels with 35% to 75% iron, 22 to 25.5% chromium, 5 to 6.5% nickel and 3% molybdenum. Now previously we have discussed about this plain carbon steels and weldability also. Now today we are discussing about mainly on the stainless steel. So there is the stainless steel, as you can see. So this is the duplex stainless steel, and it is being used in chemical plant pipelines, and it is welded with special rods, higher nickel to stabilize austenite and ensure correct composition for best corrosion resistance. 50-50 or alpha by gamma. It's avoid a low heat input welding, control maximum interpost temperature, can be susceptible to hot cracking as well. Now, effect of alloy elements. Solution hardening effective elements are tungsten, molybdenum, and chromium. Solution hardening weaker elements are iron, copper, cobalt. Gamma prime formers are nickel, titanium, and aluminum. Gamma prime is affected by cobalt, iron, tungsten, molybdenum, tantalum. Carbide formers are titanium, zirconium, Nb, and Ta. Carbide affected by COMO, FeW. From this COFeMOW are used for same purpose like solid solution strengthening, affects gamma prime phase, and affects carbides. Now, steel weld metallurgy. The grain structure of steel will influence its weldability, mechanical properties, and in-service performance. The grain structure present in a material is influenced by the type and number of elements present in the material, the temperature reached during welding or PWHT, the cooling rate after welding and or PWHT. Now the factors affecting on weldability. Melting point of metal, that is materials with medium melting point can be welded very easily. Thermal conductivity, material with high thermal conductivity is treated as difficult to weld materials. Reactivity, if the material reacts with air, water or surroundings, it becomes difficult to weld. Coefficient of thermal expansion of metals, material with high thermal expansion coefficient, it becomes difficult to weld. Electrical resistance, higher the electrical resistance of the material, it becomes difficult because it requires lot of heat energy. Now the surface condition, material with dirty surface, it becomes difficult to weld. Strength and brittleness of metal at high pressure, composition of metal, treatment, heat treatment carrying out before and after welding, thermal properties of the metals. From the above mentioned factors, whichever the material is influenced by maximum number of factors, the corresponding material is treated as very difficult to weld, and whichever the material is influenced by least number of the factors, the corresponding material is treated as very easy weld material. Now again, the classification of the steel, we have already defined that in plain carbon steels we have low carbon steel 0.01 to 0.3% carbon. In medium carbon steel we have 0.3 to 0.6% carbon. In high carbon steel we have 0.6 to 1.4% carbon. So plain carbon steels contain only iron and carbon as main alloying elements. Traces of manganese, silicon, aluminum, sulfur and phosphorus may also be present. So in low carbon steel it is also known as mild steel. It has tensile strength of 555 Newton per millimeter, hardness of around 140 bhn, and this bright fibrous structure, and it is tough, malleable, ductile, and more elastic than wrought iron. Its melting point is around 1410. Now low carbon steel, these are the plain carbon steels, very low content of alloying elements and small amounts of manganese. Most abundant grade of steel is low carbon steel, greatest quantity produced, least expensive, not responsive to heat treatment, cold working needed to improve the strength, good weldability and machinability. Now HSLS steels, it has got high strength low alloy. Alloying elements like copper, vanadium, nickel and molybdenum up to 10 weight% have high strength and may be heat treated. In medium carbon steel, we have the carbon content in the range of 0.3 to 0.6%, can be heat treated, austenizing, quenching and then tempering. Most often used in tempered condition, tempered martensite. Next is your medium carbon steels have low hardenability. Addition of chromium, nickel, molybdenum improves the heat treatment capacity. Now, heat treated alloys are stronger but have lower ductility. Typical applications are railway wheels and tracks, gears and crankshafts. Mild steel. The mild steel or low carbon steels contains up to 0.3% carbon. It may be classified as follows: dead mild steel, that is 0.05 to 0.15% carbon. It is used for making steelware, sheets, rivets, screws, pipe, nail and chain. It has tensile strength of 390 Newton per millimeter square and a hardness of about 115 BHN. Mild steel containing 0.15 to 0.2% carbon has a tensile strength of 420 Newton per millimeter square and hardness 125 BHN. It is used for making camshafts, sheets and strips for fan blades, welded tubing, forging, drag lines, etc. Mild steel containing 0.2 to 0.3% carbon has a tensile strength of 555 Newton per millimeter square and a hardness of 140 BHN. It is used for making valves, gears, crankshafts, connecting rods, railway axles, fish plates, small forgings. Now, high strength low alloy steels, HSLA. It is primarily utilized for structural applications requiring high strength. HSLA steels utilize low carbon content with small amounts of alloying elements and a variety of controlled processing parameters to obtain high yield strengths greater than 275 MPa. It has got good toughness, weldability, formability, and atmospheric and other corrosion resistance. Availability as hot rolled sheet, strip, and plate, hot rolled and cold finished bar, tubing, pipe, and structural shapes. Can also be furnished as cold rolled sheet and forgings. Applications include construction of bridges, buildings, drilling rigs, vehicle parts, peeling ships, etc. Described in at least 18 ASTM specifications which provide chemical composition, mechanical properties, forms available and intended uses. Many of these specs list several grades with different strength levels. Now, austenitic, ferritic, martensitic, we have this magnetic response as generally no in austenitic. For ferritic, yes, and for martensitic, yes, and for precipitation hardening, magnetic response is yes. For duplex, is also yes. These are the characteristics and properties of stainless steel. Weldability of austenitic stainless steel is very high, whereas for ferritic is low and martensitic is low. Precipitation hardening is high, duplex is high. Now, high temperature resistance for austenitic is very high, for ferritic is high, for martensitic is low, and for precipitation hardening is low, and for duplex is low. For austenitic stainless steel, low temperature resistance is very high, ferritic is very low, and for martensitic is also low, and for precipitation hardening is also low. For duplex it is medium. Now, for ductility, for austenitic is very high, for ferritic is very medium, for martensitic it is low, and for precipitation hardening it is medium, and for duplex it is medium. Now, work hardening rate is very high for austenitic, for ferritic it is medium, for martensitic it is medium, for precipitation hardening it is medium, and for duplex it is also medium. Now, for austenitic, the hardenable is by cold work. For ferritic it is no. For martensitic it is quench and temper. For precipitation hardening it is age hardened. For duplex it is no. And for corrosion resistance, austenitic stainless steel is high, ferritic stainless steel is medium, martensitic is medium, precipitation hardening is medium, and duplex is very high. Now, notes as given below. For one, we have attraction of steel to magnet. Some grades can be attracted to a magnet if cold worked, measured by toughness or ductility at sub-zero temperature. Austenitic grades retain ductility to cryogenic temperatures. That is the 2 point. Next is the 3 point, which varies significantly within between grades within each group. That is, free machining grades have lower corrosion resistance. Those grades higher in molybdenum have higher corrosion resistance. Now, weldability of austenitic stainless steel, it has the following compositions: carbon percentage of 0.03 to 0.25%, manganese having 2 to 10%, silicon having 1 to 2%, chromium having 16 to 26%, nickel having 3.5 to 22%, phosphorus and sulfur having 0.08%, and this molybdenum and titanium case some case iron balance. They possess high corrosion resistance. Of all the steels, that is a stainless steel, they possess great strength and ductility and non-magnetic and so on. Applications are aircraft industry, austenitic is in process plants, cryogenics, medium corrosive. Applications used over wide temperature range. Chemical processing, that is heat exchanger, dairy industry in milk cans. Now, what is stainless steel? Stainless steel is the name given to a group of corrosion resistance and high temperature steels. The corrosion resistance property is due to a thin, adherent, stable chromium oxide or nickel oxide film that effectively protects the surface from many corroding media. When ordinary carbon steel is exposed to rainwater, it corrodes, forming a brown iron oxide, commonly called rust, on the surface. This is not protective, and eventually the entire piece of steel will corrode and be converted to rust. But when enough chromium, more than about 10%, is added to ordinary steel, the oxide on the surface is transformed. It is very thin, virtually invisible, and protective in a wide range of corrosive media. This is what we call stainless steel. There are several different types and many different grades. Ferritic stainless steel, which is having 14 to 27% chromium, martensitic stainless steel, which is having 11.5% to 18% chromium, austenitic stainless steel, having chromium nickel or chromium nickel manganese. Now, weldability, we have discussed. Okay, so we have this titanium alloys, which is for the next slide. Let us have some typical properties of discuss about typical properties of this austenitic and this ferritic stainless steels. It has got a property, has got a grade most commonly drawn, and austenitic chromium is 304, whereas a ferritic this plain chromium is 430. Corrosion resistance is excellent for chromium, austenitic chromium, whereas for ferritic plain chromium is corrosion resistance is good. Formability is very good in chromium and moderately good in plain chromium. Drawability is up to 50% in chromium, that is austenitic chromium, and for ferritic plain chromium it is up to 30%. Weldability in case of austenitic chromium is excellent, and in case of ferritic plain chromium is moderate. Weldability of ferritic stainless steels, it is having a following composition, as I already discussed: 0.08 to 1.5% carbon, silicon 1%, chromium 11 to 27%, and so on. And they possess magnetic and good ductility, and it is more corrosion resistance than martensitic steels. It has got its application in a lining petroleum industry, heating element for furnace, and screws and fittings as well. So as you can see, we have covered today this stainless steel, weldability of stainless steel mainly. So let me check if is there anything remaining to tell you about the okay. Now one last thing in conclusion of this stainless steel, I must tell you that um, this weldability of stainless steel, actually it is known for its corrosion resistance, this stainless steels, and wide range of uses in food handling and cutlery and many other applications. So stainless steel is one of the most popular metals in use today. Dozens of alloy variants make welding stainless steel more complicated than welding traditional carbon steel. However, while stainless alloys were once considered a major challenge to weld, today they are described as different as opposed to difficult among most welders. Stainless steels are high alloy steels containing a minimum of 10.5% chromium. Also, they are usually alloyed with other elements to improve heat resistance, mechanical properties, fabricating characteristics as well. And they are already I have discussed with you, that is the ferritic, martensitic, precipitation hardening, duplex and austenitic. So as you can see, there are different characteristics of and properties of stainless steel, and mainly talking about the weldability for the austenitic, precipitation hardening and duplex stainless steel have got the highest weldability among the different stainless steels. Okay, so these are the things you have to to know about when welding of stainless steel comes into the factor. So hope you have enjoyed today's class. Thank you for watching.